Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Hello students. Welcome back to another exciting physics session. Today, we are going to solve a very important problem based on an ideal transformer. Are you ready? Let's dive right in. Let's carefully read the first part of the question. An ideal transformer has a primary coil of 1000 turns and a secondary coil of 500 turns. The primary voltage is 120 volts. Always remember to note down these given values first. Our first sub-question is, what is the secondary voltage? We need to find the value of Vs. Moving on to sub-question B. What is the output power of the transformer when the input current is 5 amperes? This is a tricky one, so pay close attention. To find the secondary voltage, we can use the fundamental transformer equation. We know that the ratio of voltages is equal to the ratio of the number of turns. So, secondary voltage divided by primary voltage equals secondary turns divided by primary turns. Now, let's substitute the values given in our question. Vs equals 120 multiplied by 500 divided by 1000. Notice how we moved the primary voltage 120 to the right side. By doing a simple calculation, 500 goes into 1000 two times and 120 divided by 2 gives us our final answer. The secondary voltage Vs is 60 volts. Perfect. The key word in the question is ideal transformer. Remember, in an ideal transformer, there is no power loss. This means the input power is exactly equal to the output power. So, if we find the input power, we automatically get the output power. Input power is simply the product of primary voltage and primary current. Let's substitute the values. Primary voltage is 120 and input current is 5. So, 120 multiplied by 5 gives us 600 watts. Since input power is 600 watts, the output power must also be exactly 600 watts. That completely solves the first half of our board question. Let's look at the OR question provided as an alternative. Here is the alternative question. An ideal transformer has an input voltage of 220 volts and an output voltage of 110 volts. If the input current is 2 amperes. First sub-question here is to calculate the output current. Let's see how to do that. Let's move to part B. We need to find the ratio of the number of turns in the primary to the secondary coils. Finally, the most interesting part, part C. If an electrical appliance with 110 volts and 500 watts power is connected to the secondary of this transformer, will it get its required power? Explain your reasoning. Let's look at the solution for part B. For part A, just like before, we know this is an ideal transformer. Therefore, the input power is strictly equal to the output power. We can expand this relationship. Primary voltage times primary current equals secondary voltage times secondary current. VPIP equals VSIS. Now we just plug in the numbers given to us. 220 multiplied by 2 equals 110 multiplied by the unknown output current, Is. To isolate Is, We bring 110 to the other side. 220 times 2 is 440. So, the output current is equals 440 divided by 110 gives us exactly 4 amperes. Great. For part B, we need to find the ratio of the number of turns. By the laws of transformers, the ratio of primary turns to secondary turns, NP by NS, is equal to the ratio of primary voltage to secondary voltage, Vp by Vs. Let's substitute the voltage values we already know. That gives us 220 divided by 110. When we simplify this fraction, both divide evenly, giving us a neat ratio of 2:1. That's our answer. To answer part C, we must check the maximum power our transformer can provide at the secondary. The available output power is calculated as the product of secondary voltage times secondary current. From our previous steps, we know Vs is 110 and Is is 4. Multiplying 110 by 4 gives a total available output power of 440 watts. The electrical appliance strictly requires 500 watts to operate properly. Since the transformer can only give out 440 watts, the actual power required will simply not be available. The appliance will not work at full capacity. And that concludes this comprehensive problem on ideal transformers. Keep practicing and thank you for watching. Happy learning!